So with range and domain, like it's just one of those things that, yeah, you know, they it is what it is. So when you see a Cartesian plane is almost like open air, you know. There's x axis there, there's the x axis, there's the y axis. This goes all the way to positive infinity, all the way to negative, going upwards to positive infinity, going downwards to negative infinity. You see, that is stuff we all know. So the idea behind domain and range is that when you see a picture on this graph, your picture will have sometimes restrictions, sometimes not. So let's just let's deal with, for example, our parabola here, right? Our parabola looks something like this. There's this there, and there's this there. You see. So when we hear the words domain and range, the words domain and range are basically asking which space does this graph occupy on the Cartesian plane. Let me put it here, domain slash range. You see, the question that will be asked is which space does the graph occupy on the Cartesian plane? I don't know who it is that is calling me, but I don't have the number, so it's fine. Which space does the graph occupy on the Cartesian plane? On the Cartesian plane. You see, like that.
Okay.
So yeah. So that's what domain and range is asking you. It's basically asking you which space in the Cartesian plane does the graph occupy. So looking at the image here, right? You need to know specific things about the graph. You need to know how the graph behaves. So, for example, domain and range, we know that there are differences is that domain is a more refined version of this question. You see, this question is for both domain and range. Which space does the graph occupy on the Cartesian plane? But then domain specifically then asks which space from left to right
I remember that.
does the graph occupy on the Cartesian plane? You see, that's what domain will be asking you. It's specifically going to be targeting the left to right, you know, version of the Cartesian plane. That's what domain is. Hence why hence why when we talk about domain, we speak about x, because x is the one that goes horizontally. With range is asking a similar question, but we know what it's going to ask. It's just going to be the opposite now. So range is asking which space, yes, which space from top to bottom does the graph occupy on the Cartesian plane? You see, so that's why here the target is top to bottom, and then that's why we talk about y. You see, so when you look at our picture here, right, the way this image is, let's bring it down here. So if you look at our image, I mean, like, without having figures here, right, when we ask what is the domain of this graph, when you ask what is the domain of any graph, you need to look at the picture from left to right and see where the graph goes from left to right. You see which space from left to right does the graph occupy. So you literally have to look along your x-axis and you have to ask yourself, okay, fine, you can even start at 0, you see, and you ask yourself, going to the right, is there anything that is going to stop this graph from stretching all the way to positive infinity? Now, if you look at the way your sketch is behaving, your graph here is going down, 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 down. However, it's going down forever, right? But then as it is going down, it is stretching towards the right forever. There's nothing stopping it. Do you see?
Yeah.
Yeah. Same idea if you look towards the left. this image is going down, right? But then as it's going down, it's stretching towards the left forever. There's nothing stopping it. You see?
Mm-hmm.
Yeah. So that's why the domain of this graph is just x is an element of R, because your x values extend all the way to the right without anything stopping it. They extend all the way to the left without anything stopping it.
So let's say in the case there was a restriction, how would that look?
So we're going to use the what you call the range to discuss that question, because you see with
Okay.
domain here we are seeing that there's nothing stopping it from going left to right. There are no restrictions, there's no asymptote, nothing. So when you have this same picture now and we're asked for the range, remember range, we said it would just be asking you which space from top to bottom does the graph occupy on the Cartesian plane. Now you can even look from anywhere you want. You see, going upwards here, you can see that your graph, you will see it all the way until this specific y value here. You see that?
Oh.
Yes. So in as much as you see how this graph is behaving, you see, it has y values all the way until this specific y value. Let's say this y value was, I mean, I don't know what it is, but let's give it a random number. Let's say this is a 6. You see, so this graph, you can see that your y values go up until 6. They don't go anywhere above 6. However, if you look going downwards, you see this graph is stretching going downwards, and these arrows are showing that this will go down forever. There's nothing stopping it from not going down. This will go down forever. There's nothing stopping it from not going down. There's no turning point. There's no asymptote. There's nothing. It's just going to go down forever. So you see your y values of this graph, they are going to start from 6 going all the way downwards to negative infinity. Do you see that? Yeah. So in terms of a restriction, here it's a turning point. You see, it's literally visible. We can see that the graph does not go above 6. And you see, with domain, we will just be focusing on the picture from top to bottom. We won't even worry about left to right. We have dealt with that. That's domain. So for range, it's just asking, where is the image? Where are you seeing it from top to bottom? You see it all the way going down, but you don't see it anywhere above 6. You see it specifically at 6 also, but nowhere above. That's why the range here, you're going to say your y values are below or equal to 6. You see, because your y values start from 6 here, going all the way down to negative infinity.
Thank you.
Yeah, bo. Yeah, bo. Yeah, bo. So that's the big idea with this kind of a question, right? That's the big idea. So with everything that we have done so far, if you think of our other picture here, the hyperbola, when you're looking at the hyperbola, right, let's actually even redraw it also so that we can, you know, yeah.
Okay.
So with our hyperbola, it's usually easier to determine domain and range. Pardon?
Asymptote. I could not get over that.
Yeah, asymptotes. So your asymptotes are your restrictions, because they are, you can visibly see where the graph does not go. So here this is your it cuts the x-axis, right? So here the equation of this one is x is equal to 0, and this one cuts your y-axis, right? So the equation of this one is y is equal to 0. So the easiest thing with the domain and range of a hyperbola is that, firstly, the domain, right? Let's deal with domain first. So with domain, why am I not? Let me use the pink. So with domain, remember, you have to ask yourself, where do you see the picture going upwards? Where do you see the picture going downwards? So what you can already see is your image here. You remember this curve and the other curve over there. It's for the same graph. So you can look from wherever you want. You see from here, you can see that nothing touches. Wait, domain is left to right. Okay, yeah. So if you look at domain, right, you can see that from left going to right, you can see that if you're going to start here in the middle, you can. The graph, you don't see it anyway here. You see, it doesn't touch anything here. You see. However, anything towards the right, you already start seeing the image, because you can already see that this curve here, right, it's going to stretch. You see here, it's telling you that it's stretching and it's going to get close to the line, but it won't touch it. So you can already, that's how we're seeing that the domain here, it's going to be everything bigger than 0. Everything bigger than 0 going to positive infinity, you see? And then looking to the left, this is showing us that the graph here is going to come close to 0, but it's not going to touch 0. So we know that the domain is everything from 0 going to the left. That's why we say here, our domain here, we can say x is bigger than 0 or x is smaller than 0. You see, because this is automatically saying that anything below 0, anything above 0, but nothing specifically at 0. You see it?
Yeah.
Yeah. So with the range, it works the same way. Range here, you can already see, coincidentally, it just doesn't touch 0. But then it's going to come close to the 0. Because remember, range, you're looking from top to bottom now, you see? So going upwards, the graph is going to go everywhere to infinity. But then coming down, it's going to come down, but not touch this line here, you see? So we can see that the graph, you see it everywhere going upwards. And then obviously the way this curve is behaving, you can see it's going to come close to the 0 there, but it won't touch the 0. But then apart from that, it's going to go all the way downwards to infinity, you see? So we can see the image goes down all the way to infinity, goes up all the way to infinity, but it does not touch 0. So the range here, we can easily say y is bigger than 0 or y is smaller than, no, y is smaller than 0 or y is bigger than 0, you see? Y values that are bigger than 0, y values that are smaller than 0. Those are what, that's where our graph goes. That's the space that our graph occupies on the Cartesian plane. Do you see?
I see it.
Yeah.
It's so simple. What has been bugging me all this time? Jeez.
Ooh, well, I mean, it is simple, because with some cases, right, your answers will just literally usually be given as for domain, because it's a hyperbola. The easiest thing you can just do is to say x is an element of R, but then x is not equal to whatever the asymptote is. For range, you do the same thing. Y is an element of R, but then y cannot be equal to whatever the asymptote is, you see. These two versions of the answer, they both mean the same thing. You can choose to write it like this. You can choose to write it like this. Because this is saying that your x values, they're everywhere. All the way to the left, everywhere to the right, but then only excluding the 0. For the range, same thing. All the way up, all the way down, but excluding the 0 specifically, which is the asymptote there. You see? So to help it like to help it stick, you know, let's use an example where the asymptote is not the x-axis and the y-axis. So here, let's say this is going to be -1, and then let's say here this is like a -2. So you can see here the asymptotes, you have here x is equal to -1, and then here you have y is equal to -2, because it's cutting y at -2, cutting x at -1. So if let's say the sketches are here, let's say you have the image over there. Let me try and make it different. Yeah, let's put the image over here. Let's put the image over there. Yo, I don't know if you can hear these guys. Pardon?
I can, but well, I just figure it's probably like neighbors or something.
Yeah, I mean, I don't know. I don't even know if they're here, outside. Shaman. These are people don't get married. Hey, it's unfortunate. No, I'm not speaking for myself.
Don't get married.
I'm just making an observation, but hey, it's fine. Let me just move on. Let's just mind our own business.
That was a very specific observation. Who hurt you? Tell me.
Huh? Yo.
Who hurt you? Oh no, tell me.
I haven't been
hit
hit
them
yet.
back for you.
I haven't been hit yet.
Oh, that's it.
No, but why am I even saying? Why am I even saying yet? Oh, okay, I did lie. Yeah, I confess my sins. I lied. Please forgiveness, please. But hey, it's fine. It's fine. We are still alive, so it's okay. So with this kind of a sketch, the domain and range is all based on the asymptote. You see, the domain you can literally say x is an element of R, but then x is not equal to -1. The range, same thing. Y is an element of R, but then y is not equal to -2. That's the heck with hyperbolas. It's the easiest one to give domain and range, literally. You see. So we could even
It's
spice things
basically
up.
the asymptotes where you'll say y not equal to 2 or -2 in this case.
Yeah, the asymptotes, remember that the parts where the graph does not touch. It's the space on the Cartesian plane that the graphs do not occupy. You see, remember, the whole
Okay.
question here is based on occupancy. You know, like where do you see this thing on this Cartesian plane? Which space does it occupy? Here we are saying that it occupies every single space from left to right, except for where x is a -1. Same here, it occupies every space going up, going down, but except for -2. You see, yeah. So when it comes to like other images, like an exponential graph, it's the same idea. You have an image, your picture could look something like this, you see, and then maybe it has an asymptote here at like +1. The range, you can see that your picture is going from 1 upwards only, but it doesn't touch 1. So here you say your range, your y values are just bigger than 1. You see, because you don't see it anywhere below 1. It's just everywhere above 1. That's where you see your picture. You see, your domain, you can see that you'll be looking at the image and asking from left to right, is there anything that stops it from going left to right? There's nothing. There's no asymptote to the right. There's no asymptote to the left. There's no turning point, nothing. So here your domain x is just the element of R, because as it stretches upwards here, it's going all the way to the right. As it's going to the left here, I mean, like, there's nothing stopping it from going all the way to the left. So that's like for an exponential graph, right? And then lastly, with like a straight line graph, we know that if it looks something like this, like just looking at it here, there's nothing, there's no turning point from left to right. There's no turning point from top to bottom. There's no asymptote from left to right. There's no asymptote from top to bottom. So that's why here the range is just y as element of R, because it's gonna go all the way up, gonna go all the way down. No restrictions there. Same with domain. You see, x is an element of R because it's gonna go all the way to the right, going all the way to the left. There's no restrictions. So your restrictions to look out for, it's basically things like the asymptotes. Let's see here, restrictions. It's obviously things like the asymptotes, and then turning point, or turning points rather. But sometimes, you know, so with turning points here, I'm going to say sometimes because of the example we're going to use just now. So when I say turning points, I'm mainly referring to, for example, here you see with the hyperbola, with the parabola, the turning point or something to look out for. But then if you have a cubic function, your turning points may be a bit misleading, because with a cubic function, the graph goes everywhere at once. You know, the turning point is not necessarily a restriction, because look, it may have a turning point there and it may have a turning point there. But you see that the graph goes above this turning point there.
Mm-hmm.
And then also here, this is a turning point, but you see that the graph goes below that turning point.
Mm-hmm.
Yeah. So that's why with a cubic function, right? Range, your graph goes everywhere upwards, because you see from here, it's still, you're still gonna see the image. Down here, you're still gonna see the image. In between these turning points, you're also seeing the image. So the range here is just y as an element of R. Domain, it's the same idea. You see, with domain, you will see the graph everywhere going to the right. There's nothing stopping it from going all the way to the right. You see, because as it stretches upwards there, it's going all the way to the right. And then from here, you see, you're seeing it there, seeing it there, seeing it there. And then as it stretches going down, you'll see it all the way to the left. So that's why the domain here is also x as an element of R. You see. That's for a cubic function. That's why with a cubic function, the domain and range will always be x as an element of R, and then yeah, range x is the element of R. No, range y is the element of R, and then domain x is the element of R. So that's the idea behind domain and range for all these kinds of graphs there. It's all about
No,
which space does it occupy on the Cartesian plane.
no lie. Like, math is unnecessarily dramatic. Half of us don't even want to use this in our career choices.
Well, that's the thing, you know. Like with I've gotten to the conclusion that when it comes to school and math and all that, it's literally just some form of, you know, resilience exercise, nothing else really.
Really, it's not even resilience, survival.
Well, resilience, survival, you know, one and the same thing, same boat, you know, same boat, same boat. You know, how much can you really take and not break, type of thing.
No,
So,
really, this is abuse.
you know, it is what you make it. You know, anything will always be what you make it. And it's easy for me to say, you know, that's why I'm saying it. Like, I won't lie. I won't lie. Words are cheap, but ish, yeah, it is what it is. So let me stop this one because we have dealt with that one. So you can see